Hello everyone, let's look at case 3, the case of no root. So if you have a rational function where the numerator is linear and the denominator is a quadratic equation where the quadratic equation has no root, or algebraically speaking, if the discriminant is strictly negative, so if you compute b squared minus 4ac, your quadratic equation does not have any root, so you cannot factor it as a perfect squared in the case of one root, or as a product of two distinct linear terms in the case of two roots. So what do? You actually have two options when you are dealing with a quadratic equation with no root. You can either use a substitution where the substitution is going to be x minus h over k, where the x minus h comes from the completion of square, and I'll show you an example of that in a moment. Or after completing the square, you will get a sum of squares, and you can also use trigonometric substitution. And actually, my next example, I will do it both ways. And normally, except if we're forcing you to do it as a specific way on an assignment, normally you can do whatever you want. Okay, you can use substitution or you can use trigonometric substitution, whatever is easier or clearer for you. So here we go. So we have an example. Let's integrate 3x plus 2 over x squared minus 2x plus 5. Again, before you try anything crazy, always think about a u substitution. And if you try here, u equal x squared minus 2x plus 5, the derivative would be 2x minus 2, which is not a multiple of 3x plus 2. So you cannot use a regular u substitution. So you cannot just use the denominator for a u substitution. Now, if you try to find roots, if you try to factor it on your own, it won't work. If you're really crazy, you can try to compute the discriminant in case you're not sure if there's no root because you can't do it, or if there's no root because there's actually no roots. So here, if you compute b squared, which would be minus 2 squared minus 4 times a, which is 1 times c, you would get minus 16, which would be negative. So we know there's no root here for that quadratic. This quadratic is irreducible. So what you need to do, as soon as you're in the case where your quadratic has no root, you have no choice, for better or worse, you need to complete the square. Of course, if right now you say, oh no, I don't know how to complete the square, I will give you the detail here of how I do it. It does not matter how you complete the square as long as you do it. So here, when I complete the square, this is the way I like to do it. So I have x squared minus 2x plus 5. So the way I like to do it is I just think about the b value. So the b value in this case is minus 2. So I take that value and I always divide it by 2. So it's always division by 2 here. There's no argument. Okay, so what is minus 2 divided by 2? That's minus 1. So I know my first square will be x minus 1 squared. But I know this x minus 1 squared will produce a plus 1. And I want this to add up to plus 5. So it will be plus 4. Again, that's the way I like to do it. I don't really care how you do it as long as you do it in a certain way that gives you that sum of squares. So my integral can be written as the integral of 3x plus 2 over x minus 1 squared plus 4. So of course, if you're really sold on the idea of trigonometric substitution, you have a sum of squares. You can actually do it using a trig substitution, and this is what I will do after doing this example using regular substitution with some manipulation. On page 46, I will redo that question using trigonometric substitution. But me, I want to do this one without using trigonometric substitution so that you can do that question if you are really sucky okay, at trigonometric substitution. There's a way to do all of them. Okay, so I'm going to do it trigonometric substitution free. Okay, so the Splenda way. All right, enough with my bad jokes. So the way I like to do it, so the trick here, you have to keep in mind if you want to use regular substitution, is that the integral of 1 over u squared plus 1 is arctan. So you need to remember that formula. That's the price to pay here. So let me just rewrite this correctly. I wrote it too small. Okay, so u, like the trick here is to remember that one. So trick, the integral of 1 over u squared plus 1 du is arctan. So that's one of the formula I want to use at some point. So here the idea, this will help you guide yourself towards the following idea. You want some shit squared plus 1. Okay, so you'll have to do some algebra that will transform this integral so that you can use this basic formula. All right, so the first thing you need to think about is you need to get rid of this 4, and you need a 1, so I'm going to factor by 4. So by factoring by 4, you're going to be dividing by 4 everywhere. So you're going to divide by 4 here and here. So you're going to get x minus 1 squared over 4 plus 1. So I'm happy here. I have my plus 1. I'm getting closer to be able to use my trick, but I want some stuff square, so that 4 is not inside the square. Pas de problème. Okay, 4 is 2 squared, so you can enter that 4 in as a over 2. So now I have something to the power 2 plus 1, so I'm really, really close. But then what I have to do, sorry, not but then, but now what I have to do is create my substitution. So once my denominator is some shit squared plus 1, you're going to use that stuff, okay, in order to use a u substitution. So that stuff inside the square is going to be u. So u is going to be x minus 1 over 2. In all these questions, if in most of these questions, if not all of them, you will need a formula for x. So if you multiply u by 2 and then you go plus 1, you also get a formula for x. So x can be replaced everywhere by 2u plus 1. So once you have u, you can compute the derivative. So be careful, x minus 1 over 2 is the same thing as 1/2 x minus 1/2. So if you compute the derivative of u with respect to x, you're going to get 1/2. And now if you isolate the x, so just by multiplying up by dx and then du by 2, you get that dx is 2 du. So we have a formula for dx, for u, and for x. We're going to do this super substitution, okay, where we're going to replace these three terms as expression that will depend on you only and not depending on your x anymore. Okay, you have to believe in you. Forget your x's. Just kidding, just kidding. So anyway, so here dx will become 2du, sorry. X is going to become 2u plus 1, and of course x minus 1 over 2, that's my u substitution. Now we just need to clean up a bit. So if you take the 2 outside with the 1/4, you're going to get 1/2. If you multiply by 3 inside, so if you multiply by 3 inside and you combine the constant, you get 6u plus 3 plus 2, which is plus 5, over u squared plus 1 du. Now, the trick is the following. Your numerator has 2 terms, so you're just going to divide your fraction as 2 things. So here, 6u plus 5 over u squared plus 1 will become, so you just take 6u and you divide it by u squared plus 1. So that's your first term, and then the 5 over u squared plus 1. And this is where, like the part that is a constant, this is where you're going to use that trick. If you have a constant over u squared plus 1, that's an application of the basic formula arctan. For the other one, you'll have to use another substitution. Okay, so there's a price to pay here if you're not doing trig substitution. But again, if you don't like trig substitution, this is the way. Okay, here we go. So if I continue here, go next page. So for the first term, I have 1/2 times the integral of 6u du over u squared plus 1. So now I'm just going to do a regular substitution. I have to use another letter because u has been used already. So I'm going to call the denominator w. So w is going to be 2x squared plus 1. So dw over du. So if you differentiate u squared plus 1, you're just going to get du. So if you want a formula for du, so just by swapping the 2u and the du, you're going to get that du is dw over 2u. So now you're getting a new integral. So here on the right side, here, I'm just using my formula arctan, 5 over u squared plus 1, that's arctan of u. the 5 times 1/2, that gives me the 5 over 2. Meanwhile, I'm doing this new substitution. So the 6u stays 6u. The u squared plus 1 becomes w. The du becomes dw over 2u. Yes, you can see here that the u, they cancel each other. And you're just left with 1 over w dw. 6 over 2, that's 3, which I push outside, and that's how you get your 3/2. 1 over w, that's now a basic integral. That's just ln of u. And in absolute value, where w is u squared plus 1, and where u is x minus 1 over 2 squared. Same thing in my arctan. So all the u's are replaced by x minus 1 over 2. And I have my final answer, okay, with respect to x. So in the end, you do go back to your x's. So this is what calculus teaches us. Okay, so it's a long question. There's a lot of steps if you're doing it that way. But the good thing with case 3 is if you follow these steps, it will always work. Okay, so it's really, really technical, but it's not difficult. You just stick to the plan and you'll get there. But there is another way to do it. Okay, you can use trigonometric substitution. So let's do this question again, okay, but then using trigonometric substitution. And in the end, you can do whatever you want. I don't care, okay, as long as you have a way to get to that answer. All right, so let's go back to page 46 and replace that example that I had there with this example, the integral of 3x plus 2 over x minus 1 squared plus 4. So we already have the square completed. So we have a sum of squares. So what's really crucial here is that when you have a sum of squares, of course here, like as usual, you try the other stuff, it's not working, but so we have a case 1. So we are trying to do a trigonometric substitution. We have a sum of squares. Hello. Okay, it's going to be a case 1 for trig substitution. So when you have a case 1, the equation, so in this case x minus 1, is going to be the opposite side of your right triangle. The 4, which is 2 squared, is going to be your adjacent side. Then by using Pythagoras' theorem, the opposite side squared plus the adjacent side squared, square rooted, is going to give you the hypotenuse. And of course, always make sure that the side you compute matches the sum of squares that you have in your question. So here we go. So now we're in trig substitution mode. The first step is to set up a ratio that links x and theta. So in case 1, you're always going to use a tan ratio. So opposite side over adjacent side. So tan theta is x minus 1 over 2. At that point, it's always useful if needed. And in these questions, typically it is needed, so might as well do it. So to extract theta, you have a formula. So arctan of x minus 1 over 2 is a formula for theta if needed. So the ratio for case 1 is always tan, opposite over adjacent. You do arctan for a formula for theta. Now, step 2, which is like just computational, the first thing you do is, if possible, isolate x. So 2 tan theta plus 1 will be a formula for x from the original ratio in step 1. Once you have a formula for x, you differentiate that formula. So the derivative of 2 tan is 2 secant squared d theta. Because the left side depends on theta, you're using d theta at the end. And then on the right side, the derivative of x is 1 dx because it depends on x. So we have a formula for theta, for x, for dx. And now the third step, which is like semi-optional, but very useful. You set up a ratio for the square root. Again, you're always going to use the adjacent side. So in case 3, cos theta is always the way to go. So cos theta is adjacent, which is 2 over hypotenuse. But we want a formula for the square root. So if you swap the square root and cos theta, you get that the square root of x minus 1 squared plus 4 is equal to 2 over cos, or 2 secant theta. And now you have everything. So our question is the integral of 3x. So we have a formula for x plus 2 dx. We have a formula for dx. And the denominator is x minus 1 squared plus 4. If I want to use the famous ratio for the square root, of course, we don't have the square root here, but x minus 1 squared plus 4 is the square root of x minus 1 squared plus 4 squared. So basically what you need is you need that 2 secant theta, but you need to square it. So we have a formula for x, we have a formula for dx, and we have a formula for the square root that we forced in this question to some extent. So here we go, substitution time. So x becomes 2 tan theta plus 1, dx becomes 2 secant squared d theta, and the square root of x minus 1 squared plus 4 becomes 2 secant theta. And now it's just algebra. So you simplify as much as possible. In this case, what happens is the following. When you are squaring it, when you're squaring the denominator, you're getting 4 secant squared. So the 2 secant squared will cancel each other. So let me just write this up. So I'm going to just use un peu de rouge pour canceller. Sorry, mon français est revenu. Okay, so here, that's secant squared and that's secant squared. So we have 2 over 4. This is how I get my 1/2 here. And I'm just going to introduce the plus 3 inside, the times 3 inside. So you're going to get 6 tan theta plus 3 plus 2. This is how I get my plus 5. And now we're almost done, actually. So this is kind of shorter. If you are comfortable with trigonometric substitution, I would say that this method is slightly faster, but at the price of mastering trigonometric substitution, which is not everybody's cup of tea. All right, so tan theta, we have a formula for it. The integral of tan theta is ln of secant theta, so we know how to turn this one. And the integral of 5 is just 5 theta. Now you're using your triangle to get rid of secant theta, which is hypotenuse over adjacent. So you're getting the square root of x minus 1 squared plus 4 over 2. And now theta, we have a formula for theta. It's arctan of x minus 1 over 2. And you have your final answer. If you multiply by 1/2 throughout, your final answer is 3 ln of the absolute value, which you don't really need here, but anyway, square root of x minus 1 squared plus 4 over 2 plus 5 over 2 arctan of x minus 1 over 2 plus c. Of course, you might be wondering, is this the same as the answer that we had? So it's not exactly looking like our answer when you're just using regular substitution to get there, but there is a way to get there. So if you want to push it so that it matches the answer that we got previously, what you do here is you want to enter the 2 inside the square root. So you can do this by turning it into a 4. So the square root of x minus 1 squared plus 4 over 2 is the same thing as x squared plus 4 over 4 square rooted. And now the idea is that since they are under the same square root, the 1/2 can fall up front using a logarithmic law, and you get your 3/2 out there. And this is how you get the answer that looks like what we had done previously with our with our super substitution. Anyways, but you can stop here at the answer in blue. This is fine as a final answer. It's just if you want to compare the 2 answers, this is what you would do. So anyways, case 3, you have a choice. You can just use regular substitution, but by, of course, manipulating the expression so that you can use the basic arctan formula, or after completing the square, which you need to do in the other case anyway. So you need to complete the square. This is you cannot avoid. So if you say, I'm not going to complete the square, sorry, okay, so you won't be able to avoid that. It's completing the square first and foremost. Then you choose to either go down the path where you only use substitution, or you have a sum of squares and you use trigonometric substitution. So it's up to you. Okay, you're a strong, independent person. Do whatever you want. But for that case, that's it. That's all. Bye-bye.